Okay, we're back live from Missoula, Montana. It is July 7th, 2014. It's got to be some kind of luckiness associated with that. We'll see. We'll see what the day has in store. All right, where did I put the course? Okay, it's right here. Now, let's just check out this Lovins lecture.
This is Duke University.
I'm very pleased to have Amory Lovins with us today in our Energy Speaker Series,
Okay,
which
sounds
we
like it popped out. I don't see the...
launched. The Duke University Energy
there
Initiative
it is.
launched earlier this semester. We've had a great semester of speakers, and I'm really thrilled that we were able to get physicist Amory Lovins with us today to have a conversation. Amory's the co-founder, the chairman, and the chief scientist of the Rocky Mountain Institute, which is an independent nonprofit that drives the efficient use of resources. Amory has been an advisor to major firms and governments.
Okay. So Amory's working. That's a good thing. So check him out too. He's kind of he's a fairly dynamic speaker. And then the Nash paper. Okay, where did you go? Where did you go, Nash? It's here somewhere. Oh, yeah. Well, let's go grab it. Oh, another thing I wanted to do, guys. Well, no, I'll do that in the third half hour. Paper notes. We'll see how well my own organizational strategy's paying off here. So, Nash, 1950. Let's just drop that bad boy right into week 2, lecture 1. Nash Game Theory, PDF. Oh boy. All right. So, for those of you who don't know who John Nash is, let's just take a look at oh my gosh, it's not John Nash. It's Russell Crowe. And now I'm totally distracted looking at the Planet of the Apes. What the heck? Well, anyway, no. What I wanted to show you here is John Nash. Let's look him up on Wikipedia. When so it looks like he's still alive. At least he was when I was last hearing about him. There he is. I think he still lives. So he went to MIT, did his grad work at Princeton. There was this movie made about him. Talks a little bit about his schizophrenia, so you can't have it all, I guess. Here's this thing on game theory. So Nash earned a doctorate in 1950 with a 28-page dissertation. Now that's a pretty short dissertation. It must have been pretty dense and pretty powerful to only be 28 pages long. I mean, that's typically just a paper. I'm not going to bust that one out because it's probably a little too technical. We're going to look at his more famous paper here in a little bit. It's just called the bargaining problem. So it looks like he had several papers come out in this time frame, and my guess would be that the bargaining problem was just probably a chapter in his thesis. That's typically what you do. You pop out a few papers and bind them together into a book and call it a dissertation. What else? Slivina explains that Nash was working on proving Hilbert's 19th problem. Let's check it out. It says, a theorem involving elliptic partial differential equations, when in 1956 he suffered a severe disappointment when he learned that an Italian mathematician, Enrico de Giorgia, who had published a proof just months before Nash, achieved his. Each took different routes to get their solutions. The two mathematicians met each other at the Courant Institute of Mathematical Science in New York during summer of '56. It has been speculated that if only one of them had solved the problem, he would have been given the Fields Medal for the proof. Wow. In 2011, an essay, Declassified Letters, written by Nash in the 50s, that's kind of wild, in which he proposed a new encryption-decryption machine. The letters show that Nash had anticipated many modern concepts of modern cryptography are based on computational hardness. So it looks like oh, he ended up at MIT as a professor, not as a student. Let me just read this. Advanced math at a local community college. Final year of high school. Carnegie Institute, now Carnegie Mellon. Okay, that's right. So he was an MIT professor, not student. In '51. So he became a professor at MIT just 1 year after The Bargaining Problem was published. Gosh, that's too bad. He became ill when his wife was pregnant with their first child. He resigned his position in '59. Gosh, and he went to the hospital. What else? So they talk about his another child he had out of wedlock, but that was not mentioned in the film. In 1954, Nash was arrested for indecent exposure. Wow. Stripped of his top secret clearance. A long time. Interesting. So he still lives in New Jersey. That's interesting. Okay, so the man's clearly a genius, but also a little has some mental problems as well. Well, who doesn't? But his seem to have really caused quite a bit of attention. All right, so that's about 8 minutes, kind of looking into his past. You're welcome to read through that. I think the Wikipedia probably does enough justice to his life. So let's look at this thing called the bargaining problem. Nash did go on to win the Nobel Prize in economics, if I'm not mistaken. Let's just see here. Recognition. Nobel Memorial Prize for Economics. Let's just look at the list. Economics. There he is, John Forbes Nash, 1994. I don't know if he shared it with these guys. Let's see what. I don't know if Harsanel and Selton were collaborators or not. Actually, it's not important. You can look at that if you want. Okay, so the bargaining problem. I'm just going to read the syllabus. There's probably some technical jargon in here that we're not quite familiar with. So let's just read through the abstract. Did I say syllabus? Ugh. It's kind of weird sitting in my room talking to myself. Let's read through the abstract kind of slowly together. says a new treatment is presented of a classical economic problem, one which occurs in many forms as bargaining, bilateral monopoly, etc. So bargaining is just that, where you have something of value and somebody else has something or some things of value, and what you're going to do is try to get the most for the least. So you're going to try to get what you want without giving away what you also want. Bilateral monopoly, meaning that the two people involved have everything. It may also be regarded as a non-zero sum two-person game. So non-zero sum means that somebody's going to win and somebody's going to lose, and somebody's going to win to a greater extent than the other person loses, making the sum positive, or it could be that both parties lose, making the total sum negative, or maybe the loser loses more than the winner, so the sum is still in fact negative. All right, in this treatment, and of course you could take this to multiple players and it becomes incredibly complicated, all to the point of the economy we have now, which is really beyond any single person's comprehension. Sorry, Gary, but we're just showing who that person is, understands the whole economy, and oh gosh, I don't know. It'd be nice to be omniscient, I guess, sometimes. Anyway, it may also be regarded, okay, in this treatment, a few general assumptions are made concerning the behavior of a single individual and of a group of two individuals in certain economic environments. From these, the solution, in the sense of this paper, of the classical problem may be obtained. In terms of game theory, values are found for the game. So that's not too bad. But we need to look a little further to see exactly what he's talking about. A two-person bargaining situation involves two individuals who have the opportunity to collaborate for mutual benefit in more than one way. In a simpler case, which is the one considered in this paper, no action taken by one of the individuals without the consent of the other can affect the well-being of the other one. So you can't take advantage of someone. You're gonna make a knowing trade. Everyone's going to know what's happening on both sides. The economic situation, monopoly versus monopsony of state trading between two nations, and a negotiation between employer and labor union may be regarded as bargaining problems. It is the purpose of this paper to give a theoretical discussion of the problem to obtain a definite solution, making, of course, certain idealizations in order to do so. Solution here means a determination of the amount of satisfaction each individual should expect to get from the situation, or rather a determination of how much it should be worth to each of these individuals to have this opportunity to bargain. Okay, so let's just get right into it. Let's just get right into it. Okay, so here's what's going on. You've got two guys, Bill, and you've got Jack. And Jack has 5 items. He's got a book, a whip, a ball, a bat, and a box. And of these, Bill's favorite is the box. It's a 4, and everything else is not so much. The book, the whip, the ball, and the bat is only a 2. Now, of these items, the favorite one of Bill's, Jack's favorite of the things that Bill owns, is the book. So the book would be much more useful to Jack than it is relative to Bill. And the other things, the whip, the ball, the bat and the box, he doesn't need quite so much. Okay, now Jack here has a pen, a toy, a knife, and a hat. Now he's got the pen, and he really needs to keep it. Maybe it's to take some notes in the book. And let's see for I beg your pardon. I'm sorry. It's Bill who really wants Jack's pen. So this middle column is Bill's utility. So Bill really wants the pen. Why does he want it? Well, shoot, maybe he's going to write something on his hand. Maybe he might take some notes in the book, but maybe the book's not much use to him unless he gets the pen. So you can already see some non-linearity starting to emerge. There's some sort of chicken and egg problems. You could look at our hydrogen fueling station and say that it has no value unless you have hydrogen cars, and hydrogen cars really have no value without fueling stations. So a lot of subtle chicken and egg going on here. Okay, but then Jack also likes his knife, doesn't care so much about the hat, or Bill doesn't care so much about the hat, and Jack, he's kind of ambivalent about most of his stuff. He's like, yeah, well, I like the knife and the hat, don't care so much about the pen, and who needs the toy? So there's non-equilibrium going on here. So let's take a look at Figure 2. And it says the graph for this bargaining situation is included as an illustration. And this is going to make it much easier to now sort of see what could unfold in this scenario. So Jack's utility gain, and this is going to be on this axis. So the higher up we go in this two-dimensional space, the happier Jack is going to be, and the happiest he could be is sort of a 10 over here. There's also Bill's utility gain, and he could be all the way out here at a 20 if he gets everything he wants. And I think it might be that let's see, if we take, it might actually just be at 22. So if all of so if Bill, let's see, if Bill ends up with the pen, the toy, the knife, and the hat, that's a 22 that he could end up with here. So that's basically, he gets all of Jack's stuff, right? And then Jack, if he gets all of Bill's stuff, that's a 4, 6, 7, 8, 9, 10. So that's as high as he can get on his utility. So if Jack gets all of Bill's stuff, he's over here. If Bill gets all of Jack's stuff, he gets that much happier. And how might you measure happiness? Well, you could measure it monetarily, right? So if he had that money, he would be, if he had the $20 and you didn't really want the $20, you would just use that $20 to buy your utility, your artifacts, your items, and then you're happier. Now, that's sort of the optimal happiness for both. But you can see here, and this is what this graph does. If Jack is as happy as possible at a 10, where is poor Bill? Well, he's down here probably at like a negative 10. Well, he's lost all of his items that he had. And that makes sense. The scales are different, but so Jack's gained everything. Bill has lost all of his articles. By the same token, if Bill is as happy as possible and gets all 22 of Jack's items, he's way up here. But you can see that Jack now though is bummed out because he's lost these 6 happy units, 1 plus 1 plus 2 plus 2, and now he's down here at the -6 mark. So that's what that is. Okay, so that's, and then, amongst those two scenarios, this one point being where Jack gets all of Bill's stuff, and this one down here being where Bill gets all of Jack's stuff, there are numerous other solutions, numerous other or combinations that this bargaining problem can take on. And what we're looking for is somewhere where both individuals maximize their happiness. So what's going on here is as we move to the right, Bill's getting happier and happier and happier, right? So he's sort of moving out here to the right. But also as we're moving to the right, Jack is getting grumpier and grumpier and grumpier. Got that? Okay. Now, as we move up, Jack is getting happier and happier, but Bill is getting grumpier and grumpier. So what you end up with is this solution point where the curvature is greatest. We'll call it that, where both guys are still happy. You could sort of say that we're moving to the right at Jack's expense, but we're also moving up at Bill's expense, and at some point both guys are equally happy and sad. Kind of okay. So both guys won, because remember, we just started here at 0. Before the trade happened, they were both they were both kind of at 0. So here we are. Turns out to be a convex polygon. It's a polygon because it's discrete. Each one of these points, each one of these trading scenarios has a given point. Convex polygon, which is the point where the product of the utility gains is maximized at a vertex and when there is but one corresponding anticipation. Okay, so here's what happens. Bill gives Jack, gives him the book, it's pretty good, gives him utility to Jack, because Jack wanted the book more than Bill, so that makes sense. Gives him the whip. That was kind of a neutral trade. I don't see any plus or minus there. Gives him the ball. Well, bummer. Didn't really want the ball so much. I'm not sure why that one exactly happened, but it was one of numerous scenarios that could happen. Also gives him the bat, so he keeps the box. Now down here, Jack gives Bill the pen. That's a really good trade. Big imbalance there. Gives him the toy, bonus, nice, a 4 versus a 1, and gives him the knife 2. Okay, so there it is. Not the hat so much. So I think this, that the one kind of curveball in there with the curveball, the ball being traded, where the utility, where Jack gets it even though he didn't really want it, ends up being the local maximum. I think it might be that if you trade the ball, you move one more point out here, but this particular line, kind of this 45-degree line, is where the solution point ends up. Okay, still there's a few more subtleties to it than that, but what I really think we should do in our EPA proposal, we need to reference Lovins in some way, and I think we really also need to reference Nash in some way as well. I mean, they're both big thinkers, and I think we need to show the EPA that we're kind of thinking big about this problem too, thinking fairly deeply about it. So let's dig into this a little bit more. I might put a little exercise together, some kind of quiz for you to dig into your own trading problem, because you can see that we can start to put relative values on our own P3, so people, prosperity, planet. And from the people part, we can go back to that very first lecture where we were looking into our own interests, our altruistic interests. Like, yeah, we would like other people to be happy, as well as our selfish. Yeah, we would like our own person to be happy. The prosperity is one where, shoot, I wish everyone else was rich, right? If everyone was rich, the chances are some money would flow my way. And I'm kind of hoping that I myself might be prosperous. So you can look at the prosperity in two ways there as well. And then planet, of course you've got the altruistic desire to have the planet be clean, bountiful, comfortable, so that nature can continue to do its thing. And then I think we also want our own little chunk of the planet to be clean and comfortable. So maybe we need to look at it that way. All right, so let's put that out there for our EPA. So let's do a little Nash and a little Lovins in our EPA. And for now, I just want to brainstorm on a little bit. So I think it's important that I don't know, get some big thinkers in on our EPA grant. All right, so we're at about a half hour. I'm going to stop the Camtasia now, and then we'll do a little EPA drafting based on our current little discussion.